Okay, as promised, here's a video on attempted, not yet learned. So I'm looking here at the top one, which is distinguishing solids, liquids, and gas phases of a pure substance. If I click on this, I'm going to just get, let's see, I'm just going to get a snapshot. Let me look at the snapshot, but I'm going to ultimately have to pull up the problem, I think, to do it, because I don't think I can move this. Oh, yeah, I can. Never mind. I beg your pardon. All right, this is perfect. So there are three sets of sketches below, right? You've seen this before because you attempted it, but it wasn't learned. All right, so we have to think about this. There's three sketches below, and it's HCl. It's a molecular formula as HCl at three different temperatures. The sketches are drawn of a sample of hydrogen chloride under a microscope so powerful that individual atoms can be seen. Only one sketch is correct for each one, okay? So we're supposed to figure out, the melting point and boiling point. So what I'm going to do, solid, liquid, and gas. So right here. So what I'm going to do is I'm going to Google those terms. I'm going to Google solid, liquid, and gas. I might Google like solid, liquid, and gas differences or something like that, and find that a solid is going to be, should have had this ready. Solid, liquid, and gas, okay? So a solid is going to be, and this I see on the Wikipedia page or any link that I find for solid, liquids, and gases. I'm going to find that number one, a solid is condensed. That means that the particles are close to each other. It's condensed. The particles are close to each other. A liquid is also condensed. That means that the particles are close to each other. And the gas is not condensed. So what do we put there? Can I just say not condensed? Right? That means the particles are not close to each other, right? So condensed might look like this, and not condensed might look like that. All right? And we'll see with the pictures that we're not expected to quantify it. Like, we don't have to measure how close they are. We can just see by looking at the pictures that one's close and one's not, okay? So a solid is condensed, a liquid is condensed, a gas is not condensed, okay? A solid now is ordered, right? And by ordered, I mean it might be, there's something that's ordered. Can you see there's some order here? Right? And a liquid might be something that's disordered. Right? Can you see that? Like, there's no pattern here. Oops, that was not a very good triangle, but ordered. And this is disordered. And this is disordered. Okay? And then a third thing is actually related to ordered, is that this is static. They're not moving. The particles are not moving. And this is dynamic. They are moving. And this is dynamic. They are moving, okay? And finally, low temp, high temp, and medium temp. Oh, I don't know. What do I put there? How about that? Low temp is solid. High temperature is a gas. Like, think about boiling water, right? Boiling water is going to be a high temperature gas, steam. Liquid's what you drink. That's normal temperatures. And ice is cold temperatures, all right? So those four things is what I find when I Google these things. And I'm also going to Google melting point. And you have to know what a melting point is. A melting point is when a solid goes to a liquid, right? And I also Google a boiling point. And that's when, I should have put this in red. Would have been nice and clean. A boiling point is what? When a liquid goes to a gas, okay? So, I wish I knew how to change that to red right there. All right, so let's keep that. So we got these notes in our mind. We're thinking about this in our mind as we do this problem. So let's go back to the problem. And there are three sketches below, and it's all HCl. So if this is HCl, can you guess which is the green? If that's HCl, which do you suppose is the green? And which is the white? Well, if you look at the periodic table, you find that hydrogen is really low, it's really small, and so that's probably the hydrogen is the white. Now, it doesn't really matter which is which, but let's just sort of get our bearings about us, okay? So now let's look at this. If we have a melting point of minus 114 and a boiling point of minus 85, that means that something bigger than minus 85 is going to be a gas, right? I'm not even looking at the temperatures below yet. I'm just looking at these right here. And something lower than 114, minus 114, is going to be a solid. And anything in between these guys is going to be a liquid, right? All right, so let's do this. Let's make a prediction about, let's look at the temperatures down here. Okay, minus 125, aha, that's below that. This is going to have to be a solid. We're definitely a solid. Now, my pen won't work here on this page, but if I was working on a whiteboard, I would write now here solid. I would write solid right below that, okay? And then I would scoot these things along here and say, which of those looks like a solid form of HCl? So let's do that. This is not ordered, so it's probably not the solid. Okay, that is ordered, but wait, it's not HCl, right? Because the green and the white are not bonded to each other. So this is not HCl, but it is ordered. Can you see that? Okay, that's also ordered. But can you see it's not HCl? Because they're not bonded. Right? Up here it says that these are molecular compound, and that means that they're bonded. Alright, so let's look further. Ah, this is ordered, and it's condensed, and it's HCl. So it's surely that. It's a solid. We're looking for a solid, right? Alright, and that's disordered, but it's condensed. So this is definitely the one. You see it? Alright, so let's look at this temperature. It's minus 68. Is that bigger or smaller than minus 85? It's bigger, right? So since that's bigger, we're expecting it to be a gas. So this is disordered, like a gas is disordered, and it's HCl. But it looks like they're pretty close to each other. These actually touching each other, right? So it's probably a liquid. Let's move along. We're looking for a gas because this is hot, right? Minus 68 is hot compared to minus 85. So, wow, that's surely the one. These are not condensed, right? We're looking for, I would have written gas down here if I could have. Looking for a gas. All right, so this is disordered, and they're far apart from each other, so it's not condensed. This is a gas. I'm sure this is right. But let's move on and see if there's another one that's like that. Okay, so this is a gas, but it's not HCl, right? Because these are not bonded to each other. So that is not the gaseous HCl that we're looking for. What about that one? Okay, well that's not HCl either because the particles are not bonded to each other, right? All right. And this is also a gas, but they're not bonded to each other. It's not HCl. So let's go back here. There we go. That's what it was. You see it? It's a gaseous HCl, and it's hot. It doesn't sound hot, right? But compared to 85, minus 85, this is high. Okay. Now minus 92, aha, that's right in the middle between these two. This is definitely a liquid. And I would write now, if I were you, I would write down liquid before you get started, because if you write it down, it gives you the extra, I don't know, it's sort of like a guardrail on a road. It keeps you from running off the road if you make notes to yourself, okay? So we're looking for a liquid. This is probably it, right? It's condensed. Remember condensed? A liquid is condensed. That means the particles are close to each other, but it's disordered, and they're moving around, and it's at moderate temperatures. Let's go back here. Sure, I'm sure that's it, right? Let's see, is this it? No, why is that not it? Because these particles are not that close to each other, right? See how these particles are close to each other? This is dynamic, or rather it's disordered, but this is probably a gas, maybe a very dense gas. Like this is a not dense gas, right? Here's a dense gas. Okay, what's the matter with this? That's probably a liquid. These are pretty close to each other. Some are actually touching. But this is not HCl because the hydrogens and the chlorines are not bonded to each other, right? So this is not liquid HCl. What about this one? This looks like it's also a liquid because it's disordered, but it's not HCl, right? It looks like it's chlorine and hydrogen, right? H2 and Cl2. Okay, so this is not HCl liquid, and neither is this, right? What's this? Say it out loud. That's a solid. Okay. All right, so we're looking for a liquid because it's in the in-between temperatures. Looking for liquid HCl, and that's it right there. All right, so that's how to distinguish solids, liquids, and gases by looking at their pictures. All right, hope that's helpful.